Right, so I'm here to talk about the long road to serverless maturity. My name's Tom Collins. I've got a lot to get through today, and it's going to go at quite a pace. I'm going to start off telling you about how the DVLA got started with serverless. Then we're going to look at some of the lessons we've learned along the way. And then finally, we're going to talk about where we are today and how we're using serverless to build services for UK drivers and the motor industry. So first, a bit about me. I'm principal software engineer, and I've personally been using serverless for around 7 years. And I first got started on serverless when I worked at the BBC here in Cardiff, and we were building components to capture TV and radio analytics. And the first project I built was quite a simple solution using Lambda and DynamoDB streams. When I was putting the talk together, I reached out to Craig, who you'll hear from later this afternoon, to ask if this thing is still running, right? This little thing we built and forgot about. It turns out it is, right? So this function has been running for 7 years, and it has very little maintenance. It's still ticking away doing its job. The point I'm trying to make here is that serverless is no longer a new thing, right? This function's 7 years old. It's not a new thing, and we've had the time to learn the patterns and learn the lessons and to develop best practice within the industry. And both the BBC and DVLA were relatively early adopters of serverless, as you can see from the timeline. When you think of the BBC, you think of innovation and creativity, right? That's one of the things it's great at. You don't necessarily think of that when you think about government. But if you look at the history of something like the driving license, technology change is natural for somewhere like the DVLA, where we've moved from paper onto punch cards, we've gone to mainframes, we've gone to on-premise, we've got legacy cloud, and today, we've got modern cloud. And for us, that's really a mix of both container workloads as well as serverless. So we prioritize both workload types. And these are underpinned by use of cloud provider integration and data services. So serverless at the DVLA started with a pilot in around 2018, and this was to build a specific external inquiry API. And we were pretty mature in cloud when we started, but we also had a little bit of help, right? So at the time, a certain Matt Lewis was working with us at the DVLA, and Matt kind of liked serverless. Right? But that wasn't enough. Matt got a little bit of help from one of his friends. So we had Jan Kui, who's a world expert in serverless, to help us get this pilot off the ground. And this is kind of what happened next. So over the pilot, we were able to sort of establish some good practice for the particular problem we were solving. And that was quickly followed by wider adoption in the organization, right? Serverless is great. We want to try this cool new tech. And that was brilliant. We had many teams trying serverless. And that led to some inconsistencies and bad practice as we scaled out across many teams. And then we reached a point of stability, probably where our use of serverless wasn't expanding, but the stability, at this point, we started to recognize some of the problems we had, whether they were inconsistencies, or maybe things we weren't doing in an optimal way from a security perspective, or in comparison with our container workloads and the rest of our platform. And this was followed then by a period of trying to improve our best practice for serverless by investing in our cloud platform, which I'll cover later, until we get to the point we're at now, which I would say is maturity, or at least relative maturity, compared to where we started. And we've got solid patterns, we've got an account process that's fit for purpose, and we're able to support hybrid workload types across serverless and container. Right, so serverless in enterprise. So when we're looking at enterprise government, where our development happens at a large scale across many development teams, often working on independent product work streams, and we've got a huge legacy footprint, often with decades of pre-existing systems, right? We're not a startup with a small focused team who are able to fully embrace serverless as the only technology in town. So I'm going to get this out the way first. For us, serverless isn't always the answer, right? There are great serverless solutions for many, many types of problems. But it's not always the best answer, right? And for us, this is okay. And we'll have a look at a few examples. Right, so this charming guy is Matthew James, and he's the lead engineer on our payment product team. And Matt and his team are brilliant at building containerized Java applications. right? And they put the payment application they built. It's been around for years. It's very, very stable. It's secure. We take over 4 billion a year, right? We're not looking to replace this with serverless. We don't need to rewrite it, and it'll do the job for many years to come, right? We're not looking at serverless in this sort of area. Another area where we're not considering serverless is in some of our core systems. So we've got a system called D90, Drivers 90. It was launched in 1990. It's over 30 years old. Yes, we're looking to rewrite it and we're going to replace it, but we're not, when we're looking at this sort of time scale, for us, we're not looking at serverless for something where we want to be confident in its stability over a sort of a 30-year time scale. Right? That's what works for us. So if we've got Java and mainframe, why do we want to adopt serverless? We've got this technology that works. But serverless is really important to us. We've embraced it, and the teams who have are really, really happy. And it's actually a key part of our technology strategy. So serverless and event-driven compute and architecture utilizing provider services is really a great fit for many, many types of problems. For us, this means things like inquiry APIs or our utility services or orchestrating long-running processes. For us, we get improved speed of delivery. We're able to offload operation and sort of maintenance to our cloud providers, and it really enables innovation and allows us to adopt many modern architectural patterns. It also means we can fully embrace cloud. So I personally think serverless is the most cloud way of doing cloud compared to something like moving VMs or some container apps. And serverless teams typically take on more responsibility for the design and infrastructure. And these skills are transferable across the whole organization. And this really aligns with our goals as a sort of technology department, which is to allow our teams to iterate quickly and deliver functional systems. We've organized our delivery and engineering teams into a product model, and we want to give them as much freedom and autonomy to use the services they need, as long as they've gone through some sort of central governance process. All right, moving on to some of the lessons. So there are lots of things you're really going to have to learn the hard way. Maybe by building things and reflecting on what could have been done better and where you could improve. And what works for us the answer may be different for you, right? And there isn't always a right answer. The first one for us is that you really can't be vendor agnostic. Okay, we had a period where we tried, certainly with our container workloads, and you really end up limiting yourself. And it really distracts you from building something functional and delivering value quickly. A function on its own is quite portable, for sure, and some of the other services like queues are trending towards commodity. But serverless is really about more than that. It's about using provider-managed services and their optimizations and abstractions over infrastructure and integration. The services become part of your approach. I've got serverless framework up there, and it's not a dig at that. We love serverless framework, and that provides some great abstractions. But for us, we embrace cloud, and that means for us AWS. On to developer experience. Okay, so serverless is going to have an impact on your software lifecycle. It's a different approach to traditional development models. The good news is that most developers want to embrace this and they want to learn. But some of the impacts it's going to have may not be so obvious when you start. Or you may have different teams who want to do things in different ways. A great example is testing, which is a big topic, and it could be a talk in its own right. Some engineers may want to apply the traditional approach they take with a Java application to a serverless solution. And proponents of serverless would say you should be deploying and testing everything against the cloud. So I'm not saying one's right or wrong. With cloud, you get the benefit of testing against real services. You deploy your code, you're testing the real deployed function and its resources. This can be relatively slow if you've got to redeploy things to execute them. Locally, you might be able to get faster test runs and maybe more control over behavior. And there are things like serverless offline and emulators of cloud services, but they're not always aligned with the latest features and often lag behind changes. Personally, I like isolated unit tests and running more of the integration test against the cloud. We've also got teams who take different approaches, and that's okay. As long as the team do it consistently, It's not a problem. And this extends to integration and testing. So what may look like an innocent change if you're rewriting a service as serverless can often have a cascading impact across your organization. Other teams may be used to pulling down a containerized version of your app, and they can run it locally, and they can run it in their build pipelines. When you move to serverless, it's simply not as portable, right? It's going to create problems. You may need to set up additional network access. Other teams may need to do this, whether it's locally or on their build servers, to be able to interact with your service. Depending on the integration patterns, this may force significant complexity onto other teams. And it's not always obvious when you make a change of that cascading impact. Observability is another good one. So typically, your organization is going to have a bunch of observability tools that are established. Maybe they're quite embedded in your organization with regards to how you report, alert, measure data across many systems. Cloud providers have some really awesome tools of their own, and they're often tightly integrated across all of the serverless services. And you're going to want to use these as well, right? They're brilliant tools. You may then end up with multiple tool sets and may need to think about how you integrate your data and other business functions across these new tools. We haven't got this one right. We use multiple tools that do similar or sort of competing concerns. And this is okay. At the end of the day, giving developers the best tool, which is often the native cloud tools, is the right answer. But it's something you really want to think through before you get to production. So if you've built this thing, you're going to put it into prod, think about the impact of the tooling change. Right, account strategy. This is a big one. So you don't really want to leave your account strategy up to individual teams. It's something you need to think about at the organization level. And we're on our third iteration of our account strategy, at least our third. Accounts within cloud and in serverless in particular are core units of design, creating isolation boundaries between data, services, and more importantly, teams. If we go back to our goals, enable teams to deliver quickly with autonomy, getting these boundaries right is something that's really important to that goal, right? So if we look at this example, and this is a bit of a naive example, I doubt anyone's actually going to do this, but if you put your whole organization in one cloud account, you can have many different products and many, many human teams all in one account, right? And this is going to lead to absolute chaos with regards to resource limits, ownership and responsibility. It's going to be impossible to manage roles and security boundaries. You're not going to do this. You probably want to split things at least by different product areas, and maybe each product team can have their own account. In this example, we've split vehicles and inquiries, but we still have multiple teams sharing accounts. You can take this further by finding the sort of natural boundaries. In this case, we've separated driver inquiry data from vehicle inquiry data within their own accounts. Once you start doing this, you really need to make it easy for people to switch between accounts, and you need to have some way of managing consistency across your accounts. This is the model we use today, and we've got over 120 accounts. And this sort of platform thinking extends to environment strategy. So in our case, each of our conceptual accounts has a non-production account and a production account. The production workloads are completely isolated, both in terms of what they're integrated with, as well as the sort of the access controls around them for human users. Within non-production, we're able to run multiple conceptual environments in a single non-production account. And that's things like dev and test, which may be formal environments, but also environments for builds, or each developer may have their own ad hoc environment. In practice, you're going to need to extend this model across authentication and other tools within your organization. So you want to think about appropriate IAM roles and how your authentication groups for each of these different account types sort of extend and how you manage them. For us, production and production access is very restricted. We only want security cleared engineers to have access, and we need appropriate auth groups to enable this. In non-production, we want it to be as close to prod as possible, but we also need to give people more freedom than in production. Right, so one huge benefit of serverless is the ability to use ad hoc and short-lived environments. For us, each time we commit code to a branch, our CI process will run some tests on the code. We'll then deploy that code into an ad hoc environment in the cloud every time we commit. We deploy the code, and we're then able to execute tests against the application running in the cloud as part of the build. And once we're finished running the tests, we can tear it down and get rid of it. And this is brilliant. I'd highly recommend you do this if you're not doing it. It'll give you a huge amount of confidence in the application you're building. And this approach works really, really well when everything in your build is serverless, right? So if you've got Lambdas, gateways, Dynamo, that sort of thing, they're quick to deploy and aren't constrained by resource limits or costs or that sort of concern. And this works really, really well. It's often likely that your application is going to have to use resources that aren't quite so serverless, so things like VPCs or databases. And this can really start slowing down your build or cause issues around resource limits. The way we approach this is to separate out some of these more cross-cutting concerns into their own deployments, and these are really natural boundaries. So your account setup, VPCs, some of the security networking, and something like a database. These are things that really change at a different rate to your application code. So we split these out, and that means when we run a build, we're able to deploy the resources required for the application, associate them with an existing VPC, or create something like a database schema in an existing database server, and then destroy it at the end of the build. This model works really, really well for us, allows us to have quick, ad hoc serverless builds. Okay, next up, we're on to data and security. So this is going to mean quite different things to different organizations. So when I worked at the BBC and we used to count TV and radio shows, the data probably wasn't that important, right? If we lose how many people watch EastEnders, the BBC are probably going to care, but it's probably not that important, right, in the grand scheme of things. When we look at something like the UK's national, and it's not a dig at the BBC, love you. When we look at something like the UK's register of drivers and vehicles, where we've got millions of sensitive records, we really, really care about the security. And cloud providers, by default, are doing an amazing, amazing job at security and protecting your data. But you're probably going to want to use additional security features that add complexity to your design and complexity to your development and integration processes. So one of these is VPCs. This is a standard networking feature across all of the cloud providers, and it allows you to sort of define a logically isolated network. And if you don't use a VPC, your architecture may look something like this, where your resources are deployed into public IP range. Yes, there are access controls around them that should prevent invalid access, but they're really more exposed than they could be. When you apply something like a VPC, you can deploy a private subnet and associate your resources with that private subnet. Right, this is better. It adds more complexity and cost, but it's more secure, and we should be doing it. This starts introducing various challenges. How do you enforce and ensure that all of your teams are using VPCs and all of your resources are associated with VPCs? It also means that every time there's a new service or feature, you need to understand how you can utilize it in the context of a VPC. Right? And these are complex challenges. Not everyone in your development teams is going to want to or need to necessarily understand this. It would be great if they did, but you need to make sure in your organization you've got a clear strategy and the governance in place to enforce this sort of stuff. And it can really add complexity, right? So if we look at this example, the drivers team want to call a private API built by the customer team. It's easy, right? You just get the host name and the open API contract. Sounds easy. But once you start adding these security features, and this is an AWS-specific example, the host names start looking like this, right? It's not so nice. And this is because once you start using VPCs and you go in between accounts, you're having to add additional infrastructure, network load balancers, etc., to provide secure routing. And this all requires configuration, often on both sides, across multiple teams. And this extends not just to the infrastructure configuration, but you end up having to consider the roles and permissions that you've got across all of your applications. And then you really need to start to watch out for the impact of change in your infrastructure. So once you've got something like this set up, if a team inadvertently redeploy their API gateway or want to move something into a new account, you're suddenly going to break a whole load of rules and configuration and integration across many teams. This is something we've been caught out with before, where a team innocently changed something because they want to move account or redeploy a gateway, and it has massive consequences across many teams. And it's very difficult to unpick. All of this complexity is worthwhile, and we should be doing this. We should be doing everything we can with regards to security, but it comes at a cost. And another example now around VPC endpoints or service endpoints, and really the impact of security and cost. This was a fun lesson, a costly lesson. So once you start using a VPC, if you need to interact with something like an Amazon service, let's say DynamoDB, and invoke the Dynamo API, you're going to have to create a VPC endpoint to allow your application to call the Dynamo service securely. So you create one, and that's OK. And you can configure your app to use it. Now, if you've got many accounts and many teams, you're going to end up with many VPC endpoints, right? Different teams teams may call half a dozen or a dozen services in each account, and you've got many accounts. And you've got multiple accounts across different sort of environment boundaries. What you end up with is hundreds and hundreds of VPC endpoints across your estate. Not only is this complicated and in creating a huge amount of configuration, it's pretty expensive, right? These things cost, in our case, £140,000 a year, right? Just for VPC endpoints, right? Which was a shock to us. So what is a very innocent security feature and a really good thing to do, once we started scaling up, suddenly created this massive cost. And it's difficult to unpick once you've reached that point. The good news is you can centralize your VPC endpoints. So we now have a platform account that's got central VPC endpoints. All of our accounts are now configured, can be configured to use them. And in our case, this is going to lead to £120,000 a year saving, right? But this requires coordination and planning at an organizational level. Briefly onto database selection. This is a huge topic. I can't give it the justice it deserves. In my view, each team or each organization really needs to learn about this and go through the pain themselves. You can save some of that pain. Go and watch or read something from Alex. Learn about single table design, listen to Alex's talks. If you're coming from a classic Java background, you're able to use things like connection pooling to balance the sort of concurrency within your applications. You may have 200 users, but you only end up using 20 database connections. When you move to serverless, each function only has its own database connection. You can have massive scale. You can run 200 lambdas, just like that. But you've now got 200 connections, right? And this sort of thing, over all of the years we've been doing serverless, the number of debates and challenges we've had around this is never ending, right? It's something we still haven't got quite right. Typically, when you're doing serverless, you'll have an architecture that looks like this, and it's great. API Gateway, Lambda, Dynamo, it's brilliant. You need to avoid falling into this trap. NoSQL, Dynamo is awesome. No overhead, it's cheap, it's instant. We can model everything as a single table design. We definitely know our access patterns. And a bit of time passes, and now there's some more complex access. You go, all right, we can stream our data into another database, right? And then you end up with something like this. What was a simple architecture now has streaming, you've got OpenSearch, you've got dead letter queues, you need to worry about consistency between your data stores. It's a great pattern, but you don't always need this level of complexity. Something like this may be okay if you don't need global scale. Sometimes a relational database with a good set of indexes goes a long way. Or even something like this, right? Right, on to the last section. So this is really about serverless maturity. Once you've been through many iterations of serverless, you'll start to know what works for your organization. Going back to our goals, we've really invested in what we call DVLA Cloud Platform, with the overall design being managed by our specialist cloud teams, with collaboration with the dev teams and our cloud providers, with a sort of shared responsibility model, all working towards a common goal. We've established a clear account strategy with an org structure and workload units. We've set up many accounts and we now need to migrate. It's a lot better if you can think about this before you get a mature strategy. We're able to deploy our default accounts with 13 lines of YAML, right? This is brilliant. We can set up templated accounts with a little bit of configuration using metadata for tagging. Our default accounts now come with a vended VPC, security control policy, centralized log shipping, security, alerting, all integrated out of the box. We want product team autonomy. We want teams to own their infrastructure. But we also need to balance sort of governance, stability, and innovation, right? So how have we done this? We have security control policies in our default accounts that enforce things like all lambdas must run in a VPC, all queues must have a customer managed key, no public S3 buckets. And we've got a suite of these rules, so teams, even if they tried to, they couldn't do something that we've deemed insecure. We've adopted boundary policies, which define the maximum permission set for different types of resource, whether it's Lambda or step function. And that includes what you can do cross-account, what operations you can invoke on different types of services. And then we give dev teams complete autonomy to use that maximum permission set. And we collaborate to sort of expand that boundary policy and make it work for our needs. So given all the complexity and challenges I've mentioned, is it really worth it, right? It sounds quite complicated, and I've mentioned lots of things that are hard to do. But the rewards can be great, right? So let's look at the payoffs. When we pull it all together, we're able to use serverless and event-driven architecture to do amazing things, right? We put serverless at the heart of our new driving license services. For signature and photo processing, we're able to use S3 events to trigger functions and invoke recognition to do face detection. Not sure who this guy is, though. We're able to model complex event-driven processes and manage process orchestration using the sort of optimum cloud and serverless managed services like step functions. And this includes modeling things like human interaction, where we get staff to review and approve photos. All of this with serverless compute, where we only pay for the state transitions. And to finish, this really all comes together for us in hybrid workload types. So I mentioned we balance container and serverless workloads. And typically, things like our application flows will really run across both of the workload types seamlessly. And this for me, is where serverless and cloud really shines. So in this example, a UK driver can come along to a containerized UI, submit an application, which will go into our serverless application backend. We're able to integrate out synchronously and asynchronously to other services and utilities, regardless of their workload type. Our staff can use containerized UIs to approve and review photos. We're able to pass control back to a Java adapter, and then finally bridge across to our mainframe to complete our transaction. As I said, for us, it's this combination of the right tool and the right workload type and the right approach that gives us the most value from cloud. We can do this sort of securely and consistently across our organization and across many teams. Okay, that's it from me. Thank you very much. Thanks for listening, and a special thanks to Matt and the organizers for putting on this great event.